All right, so let's look at what happens when you reduce an amide to an amine. And when you're reducing it, you're basically going to be taking this oxygen off and replacing it with two hydrogens. So our lithium aluminum hydride is going to be a good reducing agent here. And we're mostly concerned with a hydrogen that it has. And so the book draws it out like this, where it has just this hydrogen ion. And the hydrogen attacks at the carbonyl carbon, and these electrons get kicked off in order to form this O minus NHCH3. We haven't done anything there. And now we've added this H. And I sometimes like to draw these in green just to sort of remember that when you go to draw the molecule later, you don't have to write those in. And so now we've got a lone pair on this nitrogen. We've always had that. And we have a tetrahedral intermediate, a four bonds to this carbon atom. And so the nitrogen can actually donate electrons into this bond here to make a double bond. And that effectively kicks this oxygen atom off, because what we aren't really paying attention to is that the oxygen atom is really attached to this aluminum H3. And so when we kick the oxygen off, that's good. But just remember that lithium aluminum hydride is a reducing agent. That's the main thing. And if you look at lithium aluminum hydride, it's really an aluminum with 4 bonds to hydrogen, which has a negative charge, and a lithium counter ion. And so that negative charge actually connects to it gives off a hydrogen, and that gives it a neutral charge, and then the oxygen can attack it and form a bond. That's just sort of what's going on, but I wouldn't focus too intently on that because it's not the main thing that we should focus on in a reduction. So if we follow our arrows here, we'll get oxygens left. We have now formed, we have our R group still here. We have a hydrogen here still that I can put in green just to keep track of it. And we have a nitrogen that's formed a double bond to that carbon, and it still has a CH3 bond. And has it always been NH2? No. And it has an H. And so that's 1, 2, 3, 4. This should have a positive charge. And so we can give those electrons back to the carbon if we add another hydrogen. So lithium aluminum hydride can come in again with another hydrogen, negatively charged, and attack that carbonyl carbon, kicking out these electrons back to nitrogen, giving us something that looks like, now we have a hydrogen here, our R group, and our NHCH3. And so we've neutralized the nitrogen atom. We've gotten rid of our oxygen completely. And if we rewrite this, we can say that we have NCH3H. And you don't have to draw those hydrogens in. They're understood to be there. And so now we've formed a amine. And this one's secondary. But you could do this with a primary amine where you just replace the CH3 group with another H. And that's the way you get a reduction of an amide to an amine.